concept of the anaerobic digester came about because of the development at Poundbury. When Poundbury was built, one of the conditions was that 20% of its energy had to come from renewable sources. The Duchy of Cornwall didn't want to buy their green credits from wind turbines in Scotland. What they wanted to do is something that gave local sustainability and local employment. We, as part of JV Farming, came up with the idea of an anaerobic digester.
Anaerobic digestion is where organic matter, such as crops or food, is broken down by bacteria in the absence of oxygen. What these bacteria produce when they break down the organic matter is methane that can then be burnt as a fuel, which can then be used to make electricity, or the gas can be cleaned, which is done on site and injected into the grid.
We developed this with a joint venture farming business with the Duchy of Cornwall, ourselves JV Farming, and APB, our agricultural consultants. The three of us came together to form a company called JV Energen LLP.
The site was chosen because of its close location to Poundbury. During construction we split it into 3 phases. We started with the groundwork and the construction of the silage pits, during which we constructed our bonded area, which we would fit the AD plants. We then moved on to our second phase, which was the construction of the AD plant itself and the CHP. This was completed by March and allowed us to supply electricity to the network and for ourselves to operate the AD plant. The third phase was then the construction of the gas cleaning, which was just recently completed towards the end of September.
Our feedstock comes from 2 sources. Local farmers use maize and grass as an arable break crop, and also from local food factories that we get things like potato waste from Weymouth and chocolate and cereal from Dorchester. It's very important that we don't go beyond the 20-mile radius to keep the carbon footprint as low as possible. What we have behind me is maize kept in a clamp. We also have grass silage stored here. Earlier on you saw the maize being transported from the clamp here into the feed hopper. We fill this up approximately once a day. From here it's fed up into the digester, and that's done on an hourly basis.
Although the maize is added every hour, it takes 30 days to digest in the digester. During this time, mixers continuously agitate the digestate to encourage the gas produced by the bacteria to be released.
Here is the truck that we have delivering potato waste. We get approximately 3 deliveries a week, and it comes from Weymouth. It comes from a potato factory where the peelings of potatoes, parsnips, carrots are brought in and pumped into our slurry store, and then from the slurry store it's pumped on an automated system into the digestate store along with our maize. We're now in the technical building. Here we've got schematic drawing of the plant itself in operation. This is shown also on our laptops and our iPhones, so we can monitor the plant at all times. Screening through, you can see that you've got the feed hopper here, which is in operation at the moment. Here we control how much feed we put in per hour. 24 times a day, it actually puts in exactly what we want.
This is an app on the phone that lets me control different parts of the AD plant, letting me know how much each feed hopper has fed in so far today. This app also allows me to go to different parts of the system. Here we go to the slurry store control. If you just listen, I'm going to turn on one of the slurry stores in the foreground.
We've got the digester. This is where the whole fermentation process takes place, and we monitor on many levels what's going on in here. Furthermore, we've got the post fermenter. Here we store the digestate in green and where the gas is stored in yellow. Here we have an oxygen injection unit. This injects oxygen into the fermenter. This encourages aerobic bacteria to digest the hydrogen sulfide and deposit the sulfur back into the digestate. This is good for our fertilizer later on when we use it. The separator behind me separates out the solid part of the digestate and is used as fertilizer on our own land. The plant behind me is designed by Agrifirm Technologies. They design plants for whatever products that you have available. For us, maize and grass silage plus food waste. This plant is specifically designed for that requirement.
Our CHP is an engine which burns biogas to generate electricity. It also takes the heat from the engine and from the exhaust and puts it through a heat exchanger so that we can then use it on site as a domestic heating supply.
When we first looked at gas cleaning, we were concerned about the complex technology and how to facilitate it from a bit of kit that cleans the gas to a bit of kit that puts it into the gas main. So we joined in with Southern Gas Network to help us create an easy solution of going gas to grid.
This is the gas cleaning machinery made by DMT. The basic process is that the biogas comes in and is sucked through these large black containers. Its job is to take the biogas, filter it and concentrate the methane so that it can then be injected into the national grid. The biogas then goes to this large blue compressor. The compressor compresses the biogas and it is then forced through the membranes which are inside the cabinet. These membranes take the biogas and separate the carbon dioxide and the methane. We are now in the network entry facility, which is a building owned by SGN. This is where the biomethane gets tested before it goes into the national grid. To my right are the sensors that are used to test the biomethane to see if it is in specification. One interesting machine is this one here, which is registering the oxygen. We have quite a low figure. To my left is the Odorant Injection. The biomethane has no smell, so odorant is added to it just like natural gas to ensure that the public can detect a leak if one were to occur. And finally, over to my left is the meter registering the amount of gas going into the grid, and that's how all the payments, etc. are measured. Over here we have a computer screen which shows the graph of the quality of the gas and how it changes and stays in the specification that is required. Below this is the control system whereby all the valves to allow entry into the grid are controlled. And finally the gas meter, which registers the amount of gas going into the grid per hour.
During the summer, when we're in full production, we will be supplying enough gas for 56,000 homes, and during the winter, 4,000 homes. The plant at the moment is in its infancy, but in the long-term future, we would like to be able to develop better uses for our electricity, supplying electricity directly to people running electric buses or streetlights. And now that we've proved that the technology is there to deal with it, we hope with our partners, SGN, we'll be able to develop this throughout the UK using anaerobic digestion and methane gas to supply the gas network to make a sustainable future.